Hello, welcome to the video. In this lesson, we're going to be looking at section 9.2. We're going to look at angles and radian measure. So, uh, central question here is how can you find the measure of an angle in radians? Well, there's a formula for it. We're going to look at that in a little bit in the lesson. But first, we're going to look at uh, angles in standard positions. So angles in standard position is to my right, I have a diagram that looks really similar to a coordinate plane, but instead of looking at x and y coordinates, we're going to be looking at angle measures. So if you look at our x-axis, if you specifically look at the right side, so like this right side here, we are going to call this the initial side. So whether we go from we go up or we go down, we always start at that spot on the x-axis. Now, if we start like how the arrow goes, like it goes here, our angle is going to be positive. If we start and go this way, our angle is going to be negative. And if you notice, each spot, whether it's an x or a y axis, has a specific degree. So as it moves, it goes to 90. When it goes to the other side of the x-axis, it's 180. When it goes to uh, the other side of the y-axis, it's 270. And when it makes a full circle, it's going to be 360. Okay, some of these angles may be larger than 360 degrees. That means we have to make another pass around uh, our coordinate plane. So we have some examples here. They're asking us to draw an angle with the given measure in its standard position. So the first thing you're going to do is you're going to try to draw as best you can a coordinate plane. So uh, here what I'm going to do, looking at this, how I draw these is I try to illustrate, okay, um, it is, I'll go 90, 180, and the next one's gonna be 270. Well, 270 is larger than 240, so I'm gonna say that it is somewhere around here. And then I'm gonna make my arrow. So, and I'll just write in 240 degrees. Next is 500 degrees. So 500 degrees is larger than 360. So I know it's going to make more than one pass around. So I have my 90, 180, 270, 360. Okay. So if I took 360 and added 90, I would get 540. So I know that it's going to come here. So I need about another 50 degrees. And so here's my 500 degrees. For part C, we have a negative degree, and that is negative 50. So it's all these other two examples, I started upward. This one I'm going to start downward, and this one's not quite going to get to 90 degrees, so this is where my negative 50 degrees would be roughly located. From here, it says that they want you to make one positive angle and one negative angle that is coterminal with the given examples. So for the first one is negative 45 degrees. So if I drew this, and okay, I say negative 45, that's going to be somewhere right about here, negative 45 degrees. Now, what I would do to find the positive is I would just see what it would be going this way. And essentially what you're going to do is you're just going to take 360 and subtract it by 45, And my green angle around is actually 315 degrees. The next thing is they want one negative. So what I would just do is I would take negative 45 and subtract it by 360. So negative 45 minus 360 gives me negative 405 degrees. All right. It's going to be in the same spot. It's just another negative value. Okay. Because it just went 360 degrees back here. Looking at uh, 395 degrees, looking at that one, this one here is because it's already over 360, it's going to be somewhere about here. So to make a positive one, I could just figure out what it is from here to here, and I can take 395 minus 360, and I get 35. So this right here is 35 degrees. Now to take and make it negative, what you can do is you could start here and go all the way to here. And what you could do is take 360 minus that 35. It's 325, but because I did it in a negative, it's actually negative 325 degrees. So here's my positive, and here's my negative, and it still is in the same angle. Here are similar examples for what we just did. If you need more additional examples, please leave me a comment. I'm more than happy to work those out if need be. The second part is being able to convert angle measures to radians and radians to degrees. Okay, so if you have a degree, here is the formula that you are going to get for radians. You're going to take pi, and then you're going to divide it by 180 degrees. If you're trying to take and you get a radian, you're trying to convert it to degrees, you just multiply it by 180 and divide it by pi. So by dividing it by pi, the pi's will cancel out, and uh, so yeah. So again, the first thing you have to be able to identify when you're looking at conversion, are we looking at a degree or are we looking at a radian? So anytime you see the degree symbol, we're dealing with degrees. Anytime you see pi, you're dealing with radians. So for the first example, we're going to convert 120 degrees to radians. So all we're going to do is take 120, I'm going to multiply it by pi and divide it by 180. So what you're going to do is you're just going to put 120 divided by 180 in lowest terms. That ends up being 2/3. So my degree in radians is going to be 2 pi over 3. Looking at B, we're dealing with radians because I have pi. Here you're going to be multiplying it by 180 over pi. The pi's cancel. So now I have negative 180 over 12. This is going to be equal to negative 15 degrees. All right, so why is that useful? Well, it's going to be useful when we try to find arc length of a circle and the area of a sector of a circle. So here is our formula for arc length. Arc length is denoted by the variable s, and it's going to be equal to r, which is the radius times theta. Now, anytime we're looking at theta, it is going to be measured in radians. So in order for the problem to work, it must be in radians in order to um, get our result. So arc length is actually finding a portion of the circumference of that circle. Area is we're kind of almost taking like a pizza slice out of um, out of the pizza pie, and we're trying to find the area of that. And so area of a sector is 1/2 times r squared times theta. So using these formulas, we'll be able to get those specific arc length results in area of a sector. All right, so here it says a softball field forms a sector with the dimensions shown. They want us to find the length of the outfield fence and the area of the field. So outfield fence is right here. So S here is going to be equal to R, which is 200, and it's going to be multiplied by theta. Well, theta here is 90 degrees, but we have to convert that to radians. So it's going to be 90 times by pi over 180. 90 over 180 is 1/2, so it's going to be pi over 2. Okay, so 200 times by pi over 2. My exact answer is going to be 100 pi feet. Or if you're looking for an approximate answer, use 3.14 for pi, and it is about 314 feet. All right, so it kind of depends on um, what they're looking for, if they're looking for approximation or they're looking for the exact answer. For the area of the sector, it is going to be 1/2 times it by 200 squared, so that's 40,000, times it by theta and radians, which is pi over 2. So multiply all three of these numbers together. My exact answer is going to be 10,000 pi square feet. If we're looking for an approximate answer, it's about 31,416 square feet. And again, it just depends on what they're asking you. All right, so both answers are acceptable. And that is looking at angles and radian measure. I hope this helps. Until next time.